When you perform a simulation, RealFlow writes out a wide variety of different files to store particle data, motion paths, meshes, object geometry, and image maps. Many of these nodes support multiple formats to improve the exchange between external 3D programs where the simulation is finally rendered. The various files are stored inside appropriate folders for each node type. All these resources have to be managed, and this is exactly what Export Central does. It is a clearly arranged control center where you can choose from a node's available file formats, change folders, and activate the export of maps. The Export Central dialog is located under RealFlow's Export menu. Another, more convenient way is to launch this tool using the F12 key. Let's take a look at the layout. The most striking element is a simulation tree. This tree is subdivided into columns and contains a list with all of RealFlow's nodes types, like particle emitters or meshes. As long as a project is empty, there is nothing to export. But once you have added a few different nodes, you can see that the main areas become expandable. These subgroups are a one-to-one representation of the elements of the nodes window, but with one exception: daemons. The only daemon that provides export resources is a color plane daemon. The other daemons add forces or remove particles, and these attributes cannot be exported. The individual node branches are expandable as well, and a click on the plus symbol shows the node's available export resources. When you take another look at the different nodes, you will also recognize that some file formats are already active. These formats are a node's default resources, and they have been enabled automatically. This way you can start simulating without checking whether the necessary files are written or not. Some export formats even provide another level, for example an emitter's PRT format. PRT is Krakatau's native format and supports channels. These channels are used by Krakatau to control the shading of volumetric elements. You are free to decide which of these channels you want to export, but please be careful with vorticity, because this property is not active by default, and you have to enable it manually in the emitter's node params panel. Texture is another channel that is often required by 3D programs in order to create vertex maps. It is totally up to you how many resources you want to activate, but please bear in mind that it always takes a certain amount of time to write a file. With very large amounts of data, the simulation can slow down, and you should always ask yourself which export resources are really necessary. You can also deactivate all export resources, and in this case, the data will only be present during simulation time. If a node does not have any active resources, but export is enabled, you get a warning in Export Central and the Messages window. A similar workflow can be achieved with the entries on the path. This column contains the standard paths to a project's directories. The scene_dir variable is substituted by RealFlow with the name of the currently open project file. When you double-click on a path, it is made editable and can be changed. A path has to be changed manually because its associated field does not provide access to a file browser. Therefore, please double-check that the entered path is valid. Finally, there is the option column, where you can choose compression levels and image formats. To open an options drop-down menu, just double-click on the appropriate entry. Another part of the panel is a button bar on the right. These buttons provide fast resource management, and you can choose whether you want to disable export completely or write out selected nodes, like hybrid emitters. The Update Timeline Cache function is used when you want to restore the already simulated data after reset. When a simulation has been cached, you see a yellow bar on the timeline. After reset, this bar disappears, and the simulation data appears to be lost. But in fact, the cached files are still available. If the reset has happened accidentally, the simulation cache can be restored again with this button. This function can also be executed from the button next to the timeline and the Alt-U shortcut. Please bear in mind that Update Timeline Cache is not a backup function. Once the simulation has been deleted or overwritten, the already recorded data will be lost. It only reads and displays what is currently stored in the project's data folders. All settings are confirmed with a Done button. RealFlow's Export Center dialog is just one way to access a node's resources. Another method can be found when you right-click on a node, either in the Nodes panel or the Relationship Editor. Under Export, you find switches for disabling or enabling the node's export resources completely. The same buttons are also part of the icon bar. Export Now writes the active file types for the current frame to disk. The lower part of the menu lists all export resources, which are available for the selected node. There, you can change or add export resources, and the settings show up in the Export Center dialog as well. Another way of accessing some of RealFlow's export features is the Export menu. When we talk about export resources and file types, we also have to talk about initial states, because they can be seen as a special case. Initial states are required when you want to restart a simulation from a certain state or frame. The workflow is pretty straightforward, and initial states can be created for each node individually. Let's take a look at the following scene, where we have a filled glass. The idea is to use this state as a starting point for a new simulation. Switch Use Initial State to Yes, and click on Make Initial State. Now, RealFlow writes out a single file to the project's initial state folder. Then, activate the Reset to Initial State option and reset the scene. RealFlow jumps back to frame 0 and reads the initial state file. When the simulation is restarted, all of the saved data files will be overwritten, but not the initial state file. So you can reset again and again. It is also possible to create initial states for multiple objects. Just shift-click on the nodes and proceed as shown before. With rigid and soft body simulations, the process is slightly different, because here, RealFlow does not write any files to the initial state folder, but the information is stored in the BDC and SD cache files. They are stored in the Objects folder. So, if you want to create initial states from current simulations, please check if the node's export resources are active. Another thing you can observe with an object's export settings is the existence of two different SD files. The first one, in capital letters, is a global container for all of the scene objects, regardless of whether they are rigid or soft bodies, or just obstacles without dynamics. The object-based SDs, on the other hand, contain only the geometry and motion data of the selected object. They are of particular importance if you want to work with an object's cache mode, because transformations of a single node cannot be read from the global SD file. In the last chapter of this lesson, you will learn how to activate and export different image maps. When we say image maps, we have to differentiate between a wide variety of types. RealFlow supports the creation of displacement maps, velocity and vorticity maps, foam maps, and wet maps. Before a map can be created, it is normally necessary to activate this feature. Displacement maps can be written from RealWave nodes and hybrido domains. The latter type also provides velocity and vorticity maps. In hybrido, the displacement feature is located in the Ocean Statistical Spectrum panel. When you take a look at the Export Center dialog, you can see that this map type is always written as a series of TIFF files. An object's wet map feature has to be enabled with the texture panel's wet-dry texture option. The maps are always squared, and their resolution is set with the associated @resolution parameter. If you want the wet marks to vanish after a certain time, then set @aging to a value greater than 0. Finally, open Export Central and enable the wet map texture resource. The files can be saved as targets, bitmaps, JPEGs, PNGs or TIFFs. Double-click on the option menu and choose the desired format. If you want to see how the map is created during a simulation, please check the Texture option in the Display panel. If you cannot see the wet-dry tag, you can select it from the menu. The simulation shows the creation process of RealFlow's wet maps with the help of 3 cubes. With an expanded UV grid, the marks are mapped correctly. With overlapping UVs, the pattern is repeated on each side of the cube. Objects without or wrong UV coordinates appear black or gray during simulation, and the maps remain empty.